Okay, guys, so I'm gonna in the next part I want to show you that before I showed you that if you graph tables, they were a clear reflection over this line y equals x, and the point now is that I want to show you that that is still the case if I graph actual relations like this. We know I got this from the previous example, so I know that if this is my original and this is my inverse, if I graph the original, I obtain this parabola, and if I graph the inverse, I obtain this sideways parabola. So what I want to show you here is, I'm going to go ahead and graph them together so that you see what's going on. I have negative 1, 0 here. I'm going to write that 0, negative 1. I have 1, 0. I have negative 1, 0. I have 2 and 3. And it might be a little bit crowded, but bear with me, please. And I have negative 2 and 3. So again, I'm going to connect these dots and make the shape of a parabola. Very poor one, but please bear with me. So next, I'm going to go ahead and graph this guy. I know that it's a negative 1, 0. So now I have negative 1, 0. I have 1, 0 this time. I have negative 1, 0, so this one happens to match. Negative 1 and 0. Then I have 3 and 2. And 3 and negative 2. So connecting the dots here, I'm going to have something like this. So when you look at it clearly, I know that this line reflected with this line reflected with that one, this line with this one with that one, and a couple of them I can't really tell, but I have a clear picture of my transformations going on here. This one connected with this one, so you can see clearly that they're reflected. The easiest way, guys, is to just graph one, switch the x and the y. So, but the fastest thing is to just take a point and reflect it over this line. So if you just draw y equals x, you can just reflect the points across that line. But again, this is something we'll practice in class, and my guess is we might not get to it soon, but I wanted to go ahead and introduce it as soon as I could.